with this, anytime you know cosine and you're looking for sine, 99.9% of the time you just have to know that cosine squared plus sine squared equals 1. And that came from the a squared plus b squared equals c squared, because our hypotenuse is always 1 on the unit circle. All right, so all we needed to do is honestly know that cosine squared, let me bring that up. All we needed to know is that cosine squared alpha plus sine squared alpha equals 1. Because everything else is just algebra. It is plugging this 3/5 in for cosine. That is my second step. Let me change the size of this. Maybe too big. So I'm just going to take that guy and go bloop, 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 and drop it in for cosine. So that means instead of cosine, I'm going to write 3/5. Don't forget the squared.
I forgot that.
So many people will forget it on the test. They will have it written, and then they'll drop the squared, and they'll just do 3/5, and they'll take the square root, and it's not going to come out to anything nice. Remember to square it. All right? Because if I square it, then when I take the square root at the end, it should come out to a nice number. If you forget to square it, it's going to come out to a nasty number that we have to approximate. All right, so plus sine squared alpha equals 1, and then it's just algebra. It is take this number, move it over here, subtract it from 1, and then it's just take the square root of both sides. I'm going to kind of do everything in one step. I'm going to say sine squared alpha equals, and I'm going to change 1 to 25 over 25, because I'm going to subtract 3 squared is 9, 5 squared is 25, and that's going to equal 16 over 25. Does anyone hate me and not know where I got any of those numbers from? Now's the time to say it. Because I was hated in a math class when a teacher did something, and then I had no idea where they got the numbers from, and then you study it, and you're just like, I still don't know where it came from. Okay, so we're all good?
I hate you, but I know where the numbers are.
Fair enough. That's a fair enough. All right, and then I'm going to go in the same step. I'm just going to take that square root of both sides. So that's just going to leave me with sine of alpha equals the square root of 16 is 4. The square root of 25 is 5. It's plus or minus, and I am 100% done, and Mr. Pavement gives me 100% on this thing, saying, man, you nailed it. You didn't do anything wrong. Why are you mad at me?
Because it's not plus or minus.
It says plus or minus right here. When you take the square root, it's plus or minus.
It's in quadrant 1, so you know the answer.
Oh, we always get down to one answer, right? I know, right? I've forgotten all classes so far. I taught this twice and I forgot it all. This is the third time I forgot it. So what I should have done, I should have started out by saying, hey, they gave me quadrant 1 for a reason. Because in quadrant 1, all students take calculus, all are positive, so cosine's positive. My sine is positive, so my answer also better be positive. So both those are pointing to the fact that sine alpha equals a positive 4 over 5. You don't need to have that plus sign there. I'm just overemphasizing the fact that I knew which one I wanted. Cool? Yes?
You said we didn't have to write the alpha sign, right?
I did say that. That you didn't have to.
Yeah.
Sorry.
Okay.
I can. Yeah. So.
Like when we're doing the problem, we just.
Yeah. Let me just.
But then in the answer, right?
Yeah. You should write in the answer. What Nick is saying is rather than saying cosine squared alpha, he probably just did cosine squared plus sine squared equals 1.
That is what I did.
Yeah. That's 100% fine. And that's what I'd probably do in my work if I wasn't showing you an example. It just cuts down on work. Later on, we'll have to be more, because we'll have a bunch of different letters and stuff we have to keep track of. Not a whole bunch, maybe 2. Maybe we'll have alpha and beta. So you might have to keep track of something. Alpha beta. Alpha beta. All right, who's got questions from the homework? Well, you probably did. But I don't have one right now. Do you remember it all?
I don't know.
Well, you can come see me or just put a question there and
Okay.
it'll get answered. But does anyone that have it know they have a question? And they're just like... I do want to go over one because the other 2 classes went over it. And generally, if 2 classes go over it, More than one person has a problem with it. And that is like 85. So in 85, the people that had questions had no problem doing this. They said, I understand that we're going to plug that in for alpha. And they understood that they were doing sine of 3 pi over 2 divided by 2. They were just a little confused at how to simplify it. They didn't quite remember from algebra how to simplify that. There's two ways to do this one. I'm going to do the official way, and the other way is based upon the official way, but it's kind of a shortcut. So currently we have a fraction divided by a non-fraction. All right? It's a fraction divided by a whole number, maybe be a decimal. So let's call this a decimal. If it's a fraction divided by a fraction, we just do keep, change, flip. We keep the top one, change multiplication, flip the bottom one. The same thing works for this, because this really is a fraction. It's 2 over 1. 2 is really 2 over 1. So that little section right there, I could just say is 3 pi divided by 2, keep, change the sign of multiplication, flip the bottom, which is 2 over 1, which would be 1/2, which is going to equal 3 pi over 4. So that'd be finding the sign of 3 pi over 4. 3 pi over 4 must be in quadrant 2, because the numerator is 1 less than the denominator, so I know what quadrant it's in. And in fact, if you look up there, or you know it, it should be square root of 2 over 2. Okay? The shortcut to that is, if you have a fraction divided by just a decimal, you just take the decimal and multiply it by this denominator. So it's 2 times 2 is 4. So as an example, this would be pi over 3 in place of this. Well, pi over 3 divided by 2 would just be 2 times 3, so it would be pi over 6. Okay? Does that make sense for anyone that was kind of not sure where they got that number from? All right. Any questions on just that? Make sense? I didn't go too quick or anything? Make sure you're okay with that. No, it'd be sine of 3 pi over 4. Yep, it'd be sine of 3 pi over 4, which equals square root of 2 over 2. Okay? We seem oddly silent. Either we just got it before and you're like, why are you even talking to us? Or you're just like, what magic happened on the board? I'm going to assume it's the prior, and if it's the latter, please come see me and ask me. We can go through examples of that. All right, then let's just get into today's lesson. Today we're going to talk about graphing. It's the last thing we're going to talk about before we get to the test. So we just have to know how to graph sine and cosine. We're ready for the test. Well, graphing sine and cosine, the basics are, we're going to come up with a shape of sine and cosine, and we're going to use that simple shape every single time to come up with more complex versions. So we're going to develop how we got the first graph, but after that you should kind of memorize what it looks like and where the key points are. When I'm graphing the sine function, I'm going to note to myself, I don't want to graph square root of 2 over 2. I don't want to graph, square root of 3 over 2. 1/2 might be okay, but I want to avoid anything that's a fraction. And so I'm going to stick to the key points that where sine is only 0, 1, or -1. And there's only 4 points up there. And those are at 0, pi over 2, pi, 3 pi over 2, and if we bring it all back home, 2 pi. All right, so those are the main points that we're going to care about for graphing. So that means on my x-axis, I'm going to mark all those key points. I'm going to say, well, I already have 0 marked on my x-axis. My next one's going to be pi over 2. Then this one's going to be pi, 3 pi over 2, and then finally 2 pi. So I'm going to mark those. So we start with pi over 2. Then we go to pi. Then we go to 3 pi over 2. And finally we end with 2 pi. We bring it all back home. Let's go ahead and find those values. We can use this space. We're not going to copy anything down over here. So I'm going to just use this space to write all my information down. So I'm looking for the sine of 0. So my x is 0. I'm looking for what y value pops out there. So if I have sine of 0, that's that very first tick mark. Our sine is always going to be, does anyone know what sine of 0 is? Check. It's 0. It is 0. Hopefully more of you knew that. Because remember, the very first question on the test is fill out the blank unit circle with all these values. All right, then we're going to do sine of pi over 2. It's another key point. This is the one that's straight up at the top, and that is at 0.01, so my sine value is, Nick, it's 1. It is 1. So at pi over 2, we're going to go all the way up to 1. Sorry. You can just yell at me. Sine of pi, it's way on the other side, and my y value is going to be 0, or sine of pi is 0. So at pi, it's at 0. Sine of 3 pi over 2, that's going to be negative 1. And then 2 pi 0, yep. 2 pi should be the easiest. Just because sine of 0 and sine of 2 pi are in the exact same location, so they should have the exact same value. So this is the key shape. Now, I'm going to show you something you do not do. Do not, when I ask you to graph these, just make these giant triangles. That is not the graph that's there. These come from a nice unit circle, a nice curved shape. So we're going to give this a nice curved shape as well. I'm not looking for perfect artists in here, but just don't give me those straight lines. Give me some kind of curve. Because if you look at this, if I flip this over, I have a circle. It comes from a unit circle and it comes out to a circle. The reason why we can't do this and turn it into a regular circle is it'd no longer be a function. It wouldn't pass the vertical line test if I brought this all the way over. So if I did something like, if I made this, that's not a function. So in order to be a function, we have to continue the circle on down here. Now this is not the end of the sine function. The sine function doesn't just stop and end. It's just like a line, right? A line just continues on forever. The sine function continues on forever too, and we'll see that on the other page. But this keeps going up and down and up and down. But we're more concerned about just this. Because from here to here are all new values. After this, it's just going to repeat itself over and over and over. So I'm looking for what's that key section that will be repeated over and over and over. And that's what I care about. And this section that has a start point and an end point before it starts repeating is called a period. A period, and it's down here. Period is the length of a complete cycle when the graph starts to repeat. So from here all the way to here, that's one period. If I ask you to graph 2 periods, you'd have to do the same thing again. If I ask you to graph 3, you have to do the same thing again. All right, each one of those segments is a period. What was that, Nick?
It's like a wavelength.
It's like a wavelength, yep. All right, that's our period. The next thing I want to talk about, well, let's go ahead and talk about the period too. So I'm going to put period down here. Because oftentimes I'm going to ask you how long is the period? How long does it take before it starts repeating itself? Well, this one starts at 0. It starts repeating at 2 pi. So the length is 2 pi units. That's the total length of one of these periods is exactly 2 pi. So my period is 2 pi on this one. Today, all of our periods are going to be 2 pi. So we can just forget about that for right now. When I ask you what the period length is, it's 2 pi until we get to how to change that. The next thing I want to talk about is amplitude. Amplitude, and if you look at the definition down there, it says the distance between the sinusoidal axis and the max or min. Or you can say sinusoidal. Both are correct pronunciations. Well, we need to know what the sinusoidal axis is, don't we, before we measure the distance? Well, the sinusoidal axis is just the axis that runs right smack dab in the middle. It has the same amount above as it does below. So this one just happens to be the sinusoidal axis is our x-axis. That is not always the case. If I shift this whole thing up, my sinusoidal axis shifts up with it. All right, that sinusoidal axis always stays in the middle. So right now my x-axis just happens to be my sinusoidal axis. Did I spell that right? Yes. But it is not always the x-axis. All right, so then the amplitude is the distance between that and the highest point. Just use a little common sense, that's 1 unit. All right, that's all they're asking for. So my amplitude is this distance from here to the axis. That is my amplitude. Now we can use some common sense and say it's 1, right? I'm going to come up with a math equation in just a second. But if you just know it's 1, just put down 1. Right? You don't have to use the math equation if you just know it's 1. The other thing to look at is, well, if I know the distance from here to here, our amplitude is just half that distance. All right, so from our highest point to our lowest point, that's 2 units. Divided by 2 gives me my amplitude. Most of the time you can just look at the picture. And today we'll recognize how to tell from the equation what the amplitude is. So most of the time you'll never have to use this equation. But if for some reason I give you the max and the min value, and you're not quite sure what to do, the actual formula for amplitude is going to be basically what I just said. It is our y maximum, so the highest point, minus our lowest point, which is our y minimum, all divided by 2. In this case, our highest point is 1. Our lowest point is -1, so it's 1 minus a -1 over 2 absolute value, and that's just going to equal 1. Does anyone have a guess at why I use an absolute value sign? Yeah.
Because since it's like the distance from the axis to the point, there's no way it could be negative.
Exactly. It's a distance. Anytime we're talking about distance, it's going to be a positive number. It's like if I'm woodworking and I cut a board, I'm not going to measure it to -2 feet. I'm going to measure it to a positive 2 feet. So distance is positive, which means amplitude is always positive. All right, amplitude is always positive. You have to know that because there's going to be instances, even today, that are going to look like it's a negative, but you have to know it's positive. All right, and that's our sine function. That is how it's always going to start out. Sine of x always starts out that way. And most of the time when we graph these, we're going to graph this first and do everything else after that. All right, so know this shape, know these key values. All right, we're going to move on to the cosine. The cosine graph. Well, we know that cosine and sine are strongly linked. If my sine is 0, my cosine is either 1 or -1. If my sine is -1 or 1, then my cosine is going to be 0. They're flip-flops of each other. So this should have a similar shape. And we are going to, in fact, use those exact same values we did for sine. So we're going to start at 0. Then we're going to use pi over 2. Then we're going to use pi, 3 pi over 2. And finally 2 pi. And we're going to go ahead and find those values. So we're going to say the cosine of 0, well, that's going to be 1. So at 0, it's going to go up to 1. The cosine of pi over 2 is going to be 0. So we come back down to 0. The cosine of pi, that guy's -1, so we go underneath the x-axis way down here at pi. Bless you. And then we have a cosine of 3 pi divided by 2. That's back to 0. And finally, we're going to do the cosine of 2 pi, and that comes back to 1. Once again, we're going to use a nice curve. Kind of a nice curve. I mean, it's curved. It's not nice, but it's curved. Now, you might be saying to yourself, it looks a lot different than the sine, but it really doesn't. It doesn't look any different at all, because you don't have to turn the page. I'm just going to show it right now. This is our cosine. This is our sine. Notice they look almost identical, except they're shifted left. Like this cosine is just shifted left. So if you remember the fact that sine starts at 0, 0, and cosine starts at 0, 1, you know both of these shapes. Because it just follows that it goes 1, 0, -1, 0, 1. Sine, if it starts at 0, 0, goes 1, 0, -1, 0. So these shapes are very, very closely linked. So you have to remember the difference between the two. It's a pretty missed question on tests. People write the cosine graph for the sine, and they put the sine for cosine. So just remember that sine is 0, 0. That's what I always remember. I don't even worry about cosine. I'm just like, if I know that sine is 0, 0, I can get everything else from there. All right, same shape-ish. It also has the same period, because 1 period is when it repeats. So it's going to start repeating after that, so that must be 1 period. So my period for cosine is going to be 2 pi as well. And my amplitude is the same. Because if let's do that in purple, because purple's fun. My amplitude is from the highest point to my sinusoidal axis. My amplitude is right here. Just by looking at it, I know it's 1. I'm going to go ahead and do that math equation. Like I said, if you get confused with that equation, like where does that y and I forget where things go, just use your intuition, right? This is 1 unit. Just go with that. But the whole math is highest point is 1. Lowest point is -1 again, so it's 1 minus a -1 all over 2, which equals 1. And now we have the basic graphs for cosine and sine. It's what we're going to use today, tomorrow, the next day, and it'll be on the test. All right, but these are the basic shapes you have to know. All right, once again, I just want to bring something to your attention. Yours isn't colored in. It was, but it's black and white print, so you can't really tell. The fundamental cycle for sine and cosine is always between 0 and 2 pi. That is called the fundamental cycle. It's the one that we're going to draw almost every single time. Because I don't want to spend the time and draw this whole thing over and over and over. I want the main guy. For cosine 0 and 2 pi, that's the main guy as well. So if I just ask you for 1 cycle, that's the one you're going to draw. If I ask for 2 cycles, like I was saying before, you could either draw that fundamental and just keep going, or you could just start at -2 pi. That would be 2 cycles. Okay? Or 2 periods. But just so we're aware that it continues forever and ever, where our range is -1 and 1. That's the basic sine and cosine. Now we're going to go ahead and switch it up. We're going to say I don't have my regular sine and cosine. Well, that means we're doing transformations. So right below, we're going to talk about transformations. Now, any trig function can be written in this form. So this can be related with cosine, tangent, cosecant, secant, what have you. It can be written in this form, where all these letters are numbers. And each letter does a very specific purpose. We're just going to cover 2 of them today. And the first one we're going to cover is that number that hangs out right in front of everything. So if I have a number right here as opposed to 1, that is going to tell me what my amplitude is. So A stands for my amplitude. Nice how that works. So our first example is I have 3 times the sine of x. So as soon as I have a number up front, it tells me my amplitude is different. It is no longer 1. The easy part is, if I have a 3 up front, my amplitude is 3. No crazy equation, my amplitude is 3. We haven't talked about how to change the period, so our period is going to stick at 2 pi. So that means my fundamental cycle will go from 0 to 2 pi. As soon as I know it's 2 pi, I'm going to go ahead and mark my x-axis. Since it goes all the way to 2 pi, I'm going to stick with my normal pi over 2. Pi, 3 pi over 2, and 2 pi. It is not a coincidence that my period is 2 pi and the last thing I mark is 2 pi. Whenever you know your period, this is always going to end in that. And we'll see that tomorrow. Whenever I'm doing transformations, I don't typically do them all at once and try to keep them in my head. It's not hard if you just have one transformation. But if you have multiple, you're going to put multiple graphs on the same xy plane. For that reason, I would highly suggest, and I know you don't have it today, but I highly suggest in the future bringing like colored pencils or something, or pens, so you can mark multiple graphs and you can see it. If you don't have one today, that's fine. There's multiple ways to mark different graphs. So what I would do if I was doing pencil is I might do one really light, and then I might do one really heavy, and I can see the difference between which graph I'm drawing. Or I'll do one regular, and I'll do one with dashed lines, or I might do one with double lines, or something so you can see which graph we're talking about. It won't be bad today because we're just doing 2 graphs on each one. But tomorrow we're going to start doing, you might have to do 3 or 4 graphs on the same one. So it keeps it organized. So tomorrow what I'm going to do is I'm going to put my colored pencils on there. So if you need colored pencils, just grab them. You don't have to use them, but it does make things pretty nice. Okay, so I changed my amplitude. Well, before I show my transformation, I'm going to first graph a normal sine. So I'm going to graph sine of x. All right, so I'm going to mark my y-axis. Well, sine always starts at 0, 0, goes up 1, it comes back to 0, it goes down to -1, and it goes back here. So like I said, if you're just using pencil, maybe just make it a dashed line. And then just make sure you label it. Make sure you label it, hey, that's just sine of x. I don't think that's the answer, Ms. Papian. I just use that to jump off from. When your amplitude changes, what it's basically doing is it's grabbing the high and low point and tugging them up and down. If I grab these two and tug them up and down, your zeros will not move. They will not move. All right, your zeros will stay put because I'm just stretching both sides. What's going to happen is this is going to get pulled up 3 units. All right, you're basically multiplying this by 3. So that means rather than, we're still going to start at 0, 0. So I'm going to go ahead and mark 0, 0 because I'm still going to start there. And in fact, all my zeros stay the same, so I'll mark all my zeros. My highest point will now be 3 though, rather than being 1. So I'm going to bump all the way up here. Go ahead and finish that guy. And rather than be -1, it's going to be -3. Just don't get this mixed up. I'm not adding 3 to everything. I am multiplying by 3. So this is getting multiplied by 3. And if you multiply 0 by 3, it stays 0. That's why our zeros stay. And our -1 turns to -3. So I'm going to go ahead and mark this and say, hey, this is my 3 sine of x. And then we're going to go ahead and move on to the next one. Our next one is 2 cosine of x. Whatever's numbers out front is my amplitude, so that's going to be 2. Haven't talked about periods, so it's still 2 pi, which means I'm going to mark the x-axis should end in 2 pi. So that's going to be pi over 2. It's going to be pi, and it's going to be 3 pi over 2. I'm going to mark the y-axis 2 with 1, 2, 3, -1, -2, -3. Now maybe you're really good and you can jump to your amplitude right off the bat. I'm not going to because we should practice doing cosine graphs. Sine starts at 0, 0, so it must mean that cosine starts at 0, 1. And then it just goes down. It goes down to 0, goes down to -1, then it comes back up. So that right there is my regular cosine of x. Now I want to graph 2 cosine of x. So my highest point is going to be multiplied by 2. So it's now going to start at 2. My zeros stay the same. I'm going to go all the way down to -2. 0 stays the same, and now I'm going to go up to 2 instead of 1. And that guy right there is my 2 cosine of x. Any questions on those? You want me to stay on this slide? I see people writing. I know it happens quick. I'll wait here for just a second. I have -3 sine of x. My amplitude is still positive. All right, even though I have a negative number there, my amplitude is still positive, so it's still 3. Amplitude is always positive. My period is still 2 pi because we don't even know how to change that yet. So that means we're going to stick with the pi over 2, the pi, the 3 pi over 2, and the 2 pi. 1, 2, 3. -1, -2, -3. All right, I'm going to do the regular sine curve. Sine starts at 0, 0. I'm going to quickly label all of my regular sine points. Do 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 boop. Bless you. So that is just regular old sine of x. My amplitude's 3. So if it was positive 3, I'd be right here. I'd be right here if it was positive 3, but it's negative 3. So rather than going all the way up to positive 3, we're going to come all the way down to negative 3. I take that point and I flip it. So we start at 0 still. Start at 0, 0 because our zeros stay the same. And we're going to go down instead of up. The negative makes it go down instead of up. Then it's going to come back to the 0. Then it's going to go up to 3 instead of down because it's negative. And so not only did I stretch it out, I also flipped it. And that is negative 3 sine of x. Positive 3 would have been up here. Negative down there. Flips everything. All right, our next one is going to be negative 2 cosine x. I'll bring it up in just a second. I just see some people still copying stuff down. I want to make sure I'm going slow enough. If you're ever behind and you can't catch up, remember the videos are online too. Or you can copy notes from someone else. All right, negative 2 cosine x. Amplitude is always positive. So my amplitude is going to be a positive 2. Period is 2 pi until I tell you otherwise. We'll learn that tomorrow. So that means my x-axis is going to stay the same. That's nice. Pi over 2. Pi. 3 pi over 2. And 2 pi. I'm going to label my y-axis 1, 2, 3, -1, -2, -3. My sine always starts at 0, 0, so cosine must start at 0, 1. And then I just follow that pattern. It goes down and then comes back up. So that is my regular cosine of x. If I was positive 2, I would jump all the way up to this 2. But it's negative, so I'm going to go up, and I'm going to flip it down here. So instead of being at positive 2, we're going to start at negative 2 down there. Let's go ahead. I'll use purple. Zeros all stay the same. This is going to be flipped, so it's going to go to a positive 2. Zeros stay the same, and I come back down to a negative 2. And that right there is my negative 2 cosine of x. Questions on that at all? Make sure you understand this, because I can make you go the opposite direction. I can show you this graph and ask you to give me the formula in cosine. So you'd have to recognize that it's not at 1, it's at 2. So at least be at 2 out in front, and then it's flipped that it's negative 2. So you should be able to eventually look at this and actually know the equation for it, just by knowing your amplitude and which direction it's starting off as. But it all boils down to the fact that you know the original cosine function. Either way, do you know the originals? Because if you do, then you can figure out from there. All right, the last one is called a phase shift. It is called the phase shift, and that is our C. That is if I have a number inside the parentheses, and it's not a number being multiplied by x, it's being added. I want to make it clear, this could be, in this one, this could be pi over 2 plus x. It doesn't have to come in this order. 90% of the time it does. But if this was pi over 2 plus x, it would still be the same. Now, if you have a number in the parentheses that's being added or subtracted, your graph is either going to move left or right. And it's going to move in the opposite direction you think it should. And what I mean by that is, if I have a negative in here, it kind of seems like it should go in the negative direction, right? If it's negative, it actually goes right. If it's negative, it goes in the positive direction. If you have a positive sign in there, it's actually traveling left. So I always think of it, if it's in parentheses, it goes the opposite direction. I think it would. So our first one is x plus pi over 2. Our amplitude is that number that's way out front. It's actually just a 1, right, at 1 time. So our amplitude is just 1. I haven't talked about period yet, so it's still 2 pi. And it is going to shift left pi over 2 units. I already labeled this axis for you. I jumped way too high up there. I would label one that's closer, 1 and -1. If you use the top one, it's fine. It's just going to make your graph look really weird because it's really skinny and long. My regular sine graph always starts at 0, 0. Then comes up to 1, back down to 0, -1, and then back up to 0. All right. We're just going left pi over 2 units. So I always start at my first point and ask myself, what is left pi over 2? And I hope it's marked on my axes already, and it is. Pi over 2 units is exactly that far because we see it's negative pi over 2. So we're just going to shift that first point over, left pi over 2. Let me put it in red. And that means we're going to shift every single point over that many units. So this one's pi over 2 units. This one's pi over 2 units. Pi over 2 units. And finally pi over 2 units. And that will give me a graph that looks like that. All right, I have to kind of hurry up. We only got 2 minutes left. I got to push this last one because it's got some important stuff on it. First of all, our amplitude is 1 because there's no number out in front of cosine. Period is still 2 pi because I didn't change that. It's going to shift right pi over 6. So my normal cosine graph, I'm going to mark this as 1. This is -1. Normal cosine graph starts at 1, goes to 0, comes back down to -1, comes up, and goes up here. Now here's why I needed to get to this one. Is pi over 6 listed on your x-axis? We have to figure out what the distance of pi over 6 is. The easiest way to do that is to find your pi over 2, your first number here, and turn it into the denominator of 6. So I'm going to rewrite pi over 2 with the denominator of 6. I'm going to multiply the top and bottom by 3, so that's going to be 3 pi over 6. That means I have 3 sections to get to this. I have 1, 2, and I'd be at 3 pi over 6. So we're going to mark it 2 times in here. So I have 1 pi over 6, 2 pi over 6, and finally I would have 3 pi over 6. It gives us a good approximation of how far I need to shift it. I'm shifting it right pi over 6, so I'm going to shift this that far. And I'm going to shift every one of them that far. So I'll probably make marks in between all of them to match that. And so I'm going to shift them all that little distance. Little distance. Little distance. Little distance. And I'm not expecting you to mark every single one of those points, but at least mark the very last one. This guy here, which would just be 2 pi plus pi over 6, which is the same thing as 12 pi over 6 plus pi over 6, which equals 13 pi over 6. So that red one right there is my final. That is my cosine of x minus pi over 6. All right, the graphs on the homework aren't the best in the world. They didn't print out the greatest, and they're kind of small. So if you want to, just use graph paper. I have graph paper if you want to grab any. Or you can just do it in notebook paper, or you can do it right on there. It works. It's just pretty small to write stuff and write notes on. All right, well, let's get the homework done. Make sure you're practicing that unit circle anytime you have downtime. All right, everyone, have a wonderful day.